Hello guys, this episode is brought to you by Fieldpiece. Fieldpiece's next generation of vacuum pumps will cut down on evacuation time and make oil changes on the fly a breeze. They are lightweight, durable, and feature 4 inline ports plus a large oil reservoir. Get pumped about these 3 new Fieldpiece vacuum pumps available at distributors now. Learn more at fieldpiece.com or follow us on social media at Fieldpiece Products. Thanks again, and thanks for listening.
We've all been there, in the middle of a job, everything going smoothly, until boom, you're missing a part. United Refrigeration is your one-stop shop for all your refrigeration needs. Use your computer or smartphone to go to www.uri.com at any time of the day or night to check stock on your favorite brands, such as Copeland, Sporlan, Carlisle compressors, Danfoss, Emerson CPC boards and sensors, Carrel, Hussmann parts, and K2Therm. United Refrigeration Inc. is home to these brands and many more. Looking for information on refrigerant conversions or refrigerant banking? Quick access links on the homepage can get you to the information you need. All approved accounts are able to see live-to-the-minute inventory and pricing. Product not in stock at your local branch? No problem. Use the Nearby Stock feature to find a local branch that does have what you need. Are you looking for a branch address, phone number, or after-hours number? That's all available as well. Just click on the branch locator and search for your local branch. Have a model number and looking for a replacement part? www.uri.com/ARP has a vast list of quick pick replacement parts. Just search for the model number of the equipment you're working on and click the Replacement Parts tab. If you don't have an account, click the Register button and we'll have you online in no time. With more than 400 locations in North America, each United Refrigeration branch is fully stocked for immediate pickup. Our branch employees have in-depth technical knowledge, so we can help you get what you need when you need it. Visit your local store or www.uri.com/ARP today. United Refrigeration Inc. has all your solutions down cold.
The Sporlan division of Parker Hannifin Corporation is sponsoring this podcast. Sporlan is the leading manufacturer of HVAC and R components. Using quality materials and craftsmanship, Sporlan maintains a commitment to innovation, manufacturing excellence, service, and support for its customers since 1934. The company is known for its catch-all filter dryers, thermostatic expansion valves, solenoid valves, pressure regulating valves, suction filters, electric valves, controllers, supermarket monitoring solutions, chemicals, smart service tools, ZoomLock Max Press to Connect, and ZoomLock Push to Connect refrigerant fittings. If folks want to learn more, what do they do?
You can go to sporlan.com.
I guess that's Jim and John for Sporlan signing off.
This uplifting cinematic experience.
I've got something important to tell you,
The
Matt.
big story is
Dig this and dig it deep.
Hey, good effort. Way to go, way to go.
Dude, don't encourage him.
You assholes know I'm being sarcastic, right?
I've been called the songbird of my generation.
Holy shit.
I'm holding in a huge miss. So could you get to the point?
Terrible. Awful. I hated it.
War's over, man. Wormer dropped the big one.
Bloody psychopath.
High-functioning sociopath.
Yet I never thought I'd see the day when 2 such highly reputable mischief makers as yourselves douse their drawers at the side of a mall security guard.
I see you got fat.
The force is strong with this one.
What are you, 8?
You're waking the neighbors up!
You still look like a 15-year-old girl, but not hot.
Good evening, everybody, and welcome to Advanced Refrigeration Podcast. You're the host, Brett Wetzel and Kevin Compass. You look exhausted, man. What's up?
It's 105 degrees in Chicago again.
I'm sorry.
So, yeah.
Could be worse.
Everything's broke.
Could be in Houston. Could be in Ohio.
Yeah, Houston sucks, but like everything's sized for that.
Everything's sized for the right actual ambient.
Yeah.
What did you have going?
Fucked up. My laptop updated again. Like it just. Ugh. It's probably why it's cut. It's been so good. Then Windows updated. Now everything's screwed again.
Gotcha.
But
where were you at? Where were you at today?
Well, how's your week going? Oh, I was at running service calls. Just with stuff, and actually, like an interesting service call that I went on today that a couple guys missed. That I don't know if everybody knows about. Modulode compressor heads. So found a rack that had a Modulode compressor on there, and they've been having nonstop oil issues with it, with the rack and that compressor. And somebody decided not to put the unloader back on and leave the shipping blank off plate on there. You cannot do this without changing the gasket. There is a separate gasket for the unloader plate for a blank off. And the shipping gasket that comes with it is a unloader gasket. So what happens is it ends up forcing the compressor after it runs for a while and builds up discharge pressure up underneath the gasket. The gasket eventually bleeds through a little bit. It allows discharge pressure to push the Modulode heads down, and that compressor runs unloaded all the time until it overheats and eventually pressurizes the crankcase. Somebody goes there and it pushes all the oil out of the rack, a bunch of oil, and they think they have oil problems. They get everything reset. That by that time, the discharge gas bleeds out of the head. The compressor fires up. Everything looks fine, and then so on and so on, and this keeps happening more and more and more.
So was it going off on an internal overload? Like, I mean, because on the modules,
no, it was actually pressurizing the crankcase.
You said it was
it would pressurize the crankcase.
Yeah, because guys, remember, all these unloaders are suction blocking, right? So these compressors are dependent on how much cool suction gas is going over those windings and going over everything else. So if we're running unloaded all of the time, then especially on a Modulode, you're basically running maybe a third of that compressor. So you're blocking off a lot of the suction. So it's going to cause excessive heat because you're not pulling that mass flow, that nice cool gas across it.
Yeah, then and the Modulode to stick and pressurize the crankcase also.
Yeah.
So that's one thing to keep in mind. Like Modulodes are a pain in the ass.
Man, I literally so I was in California last week. I told you that we one of the things that we got to do is we got to actually rebuild a Modulode. We had the compressor was, I think it was overheating. And then, yes, it was overheating because basically the discharge gas was bleeding directly back into the suction. So it was causing the other two compressors to go off on internal on our trainer. And so, the kid that I was working with, I had him lop off the discharge because the discharge line coming out of the compressor, even with it not running for hours, was 220 degrees, which is telling you that basically all that discharge gas is rolling back through directly back into the suction. So, we isolated, we knew something was completely messed up, but we were waiting for the valve plate to come in before we, made an assumption whether the compressor was fragged or whatever. But one of the things that we did also notice when you rebuild those, where the unloader, I'm not actually sure what those pieces are called. There's this the cylinders that are on top that are for the modulode, they're like 4 inches tall. So there's O-rings that actually go inside the head that lets that thing seat in there, so it doesn't bleed by. So make sure when you do rebuild those that you do replace those O-rings as well. It does come in the valve kit. So no, I just
same thing if you do a gas changeover to change those, because they'll swell and then pressurize the crankcase.
So I'm assuming that compressor was probably installed, and quite honestly, probably the amperage was never checked, because if that gasket was in there, they would have seen that the compressor was going off or was not producing the proper amount of amperage for that pump, right?
So what I've seen, they will run, and they will run properly until it gets enough gas that bleeds on top of that piston area to push it down.
Yeah, they tell you right
and then
in the
it'll
bulletin.
unload. It'll stay unloaded.
Yeah, they tell you right in the bulletin which gasket to actually use if you're not going to be utilizing the unloader. So, but no, I just got back from
All right,
Oklahoma.
guys, let's.
Sorry.
There's like lag in between us for some reason. It's 105 in Chicago, and every phone tower is down.
You're fine.
All right, see if this works better.
All right.
Okay,
so
guys.
Tonight,
so,
this is reminiscent of like maybe about a year and a half ago.
Yeah, this has been tough. I've had good internet until every cell phone tower goes down. All right, guys. Tonight we're going to talk about racks and high ambient conditions and how to deal with the hell that I'm living right now. Right, you want to take it off since you live in hell 24/7?
Well, see, in this hell, at least, the compressors actually, or the racks are sized for the temperature that we get. I mean, typically, we're dealing with high ambient conditions on, your regular HFC chemical refrigerants is what we're going to be talking about. I mean, what can you do? Unfortunately, there are some customers out there that they want to decide to add a whole bunch of cases, upsize the compressor, and typically, like we stated before, typically you get about 15% oversized for what the condenser is actually sized for, and that's fine. It helps with going with in between the degradation of the condenser over the years, but typically people abuse that, and they're like, yeah, we could throw another 40-foot line of cases on there. Hey, we could throw another, we can get rid of that 15 horse, we could throw a 25 horse on there, no problem. So that's one thing that I don't agree with. If you're going to spend that much money doing a remodel and doing all the other stuff, if your condenser is 15, 20 years old, it might be time to change it, especially if you're changing a bunch of the load that's on there. Obviously, you want to make sure the condensers are clear, making sure there's no carpets, making sure that there's a lot of times construction will kind of mess with you. If you have more construction in one area or not, throwing out a lot of dust, it gets sucked up in there. One of the good indications that I use when I go up and check to make sure that the condenser is operating properly, I mean, first and foremost is looking at the controller and making sure it's operating at the proper TD that it should be. If the rack if it's a medium temp rack, we'd already stated that the TD can be anywhere from 12 to almost upwards of 18 degrees. So just so you understand that, if it's 100 degrees outside and the TD happens to be 15, then we should technically be running about 115 degrees saturated condensing temperature. That being said, if it's not doing that at that point, you're starting to look into all this other stuff that it might be causing it to run higher than what it should. Usually it's the condenser's blocked. Usually it's a fan out. 85% of the time, it's usually because it's impacted. I've seen, people that have been contracted to, clean these condensers, and you try to tell them the right way to do it. And they're like, well, I've been doing this for at least 3 months. I know what I'm doing. And, they're going from the bottom, throwing all that water directly up in through. So they're basically just driving all that dirt and crap back into the damn condenser. What are your experiences with that?
Oh, you mean the guys that are hired straight out of like jail to come wash the condensers?
Well, I'm not talking specific companies. I'm just saying, like, in general.
Yeah, they generally suck ass. Unless you're a Target where they like make the refrigeration contractor babysit them and shut the rack down and open up the condenser and make them do it from the top. That is the only time I've ever seen a fleet wash work.
Another thing about a lot of these condensers, when you are doing, that type of maintenance, making sure you're not just sitting there and shutting it down for the guy. Take the time that you're paid to do and investigate what the hell's going on with that condenser. Because, you could have a multitude of things. Heat craft condensers. Typically they use, I guess you call it a C-channel steel. A lot of times whenever the bearings go bad on the condenser fan motors, or you have a lot of, short cycling on those things, it ends up causing the whole bracket to actually break off the sides, and typically causing you not to have a really fun day. What'll happen is it'll
generally in the middle of the night in the rain is how it usually goes. Or at least every time it's been for me. It's been at like 2 a.m. when the fan motor drops through, and those beams suck to change too. So
yeah, you have to drill them out, because I believe they're riveted, if I'm not mistaken.
They are riveted. Yep.
Yes. So you have to cut out the rivet. Either use the same type of tool that they use from the factory, or you just bolt that thing together. Making sure you use at least a grade 8 bolt.
The rib nuts are great for a lot of things, just not that.
Also, a while back, one of the manufacturers, I'm not going to get into specifics, I don't want to throw anyone under the bus, but what would happen was the fan blades were actually breaking. What I found out is the metallurgy was actually wrong when they were producing these particular fan blades, and they were just continuing to crack around the rivets that hold the actual fan blade to the actual blade itself, and this was causing the blades on there to just snap off, and eventually it would either fling itself directly into the condenser and make you have a really bad night, or the other option, it would cause a lot of vibration, because now the fan blade's out of round, and breaks that bracket, and then the whole thing falls down in there.
Okay, so another thing, fan blades. Do not go to Johnstone or a random supply house and just grab a fan blade that they say, yeah, that fan blade will work. It has 4 wings instead of 3 now, but the pitch is the same, and yada, yada, yada. Do not do that to a condenser. That is the quickest way to cut down the efficiency of a condenser. Put the OEM fan blades in there, what they were designed to have. Moving too much or too little air across that is going to cause a massive amount of problems. Same thing with motors. I'm a big proponent of using the OEM motors. Unless they have drive rated motors in there, then I'm going to go with the US motor. But generally, I want to get the OEM motor. Try to keep it all OEM as much as you can, just for the fact that you don't want to change the specs on that condenser, because that may be an issue. I've seen it where people put juggernaut motors in there and causes all kinds of issues. Guys are putting juggernaut motors in there. The RPM slightly different. Yeah, 50 RPMs here, 50 RPMs there. Next thing you know, you got 8 different motors in there, and you're a couple hundred RPMs short.
So guys, also be aware on the older legacy stuff, stuff that's like 20, 25 years old. You'll see a lot of times, Tyler condensers. Well, Tyler didn't make a condenser. What they did was they subbed it out to WIT, which is Russell or HTPG, I believe that's the the short name for one of the companies that were in there. But those Tyler condensers for the racks, very, very particular on the fan blades. There's a certain pitch, certain amount of fan paddles, and that if it wasn't correct, you'd end up just burning up a bunch of freaking motors. And typically it was because it was completely compacted. But and once again, it was like Kevin said, hey, just this one's good. This one will work. Same thing. I'm not really a fan of the condenser fan blades that have the hub that you screw in with the 3 screws. I don't know how many times I've just seen that shit just snap off and then just cause more problems than what it's
I
worth.
refuse to use those things. They are absolutely trash. They come apart. You can put Loctite on them. And first off, who thought putting a regular screw was good on something like that? Like
they have Loctite on them. Like that's what I don't understand too. Like, I mean,
let's put a regular screwdriver, slotted screwdriver on something that's supposed to get tight, because this is 1939.
At least they're not wood screws.
They might as well be. They hold together just about the same. Those things are junk. I get so mad every time I see one of those on there. I'm like, God bless it. And I'm trying to get the hub off too, off the motor. It's just like almost impossible.
So if you are going to replace the fan blade, man, I'm not really like, if you have to replace the motor and you have to take the fan blade off, I'm not really a big fan of that. I really not, because typically when you're it's messed up because you're beating the crap out of it trying to get it off. I mean, in a pinch, yeah, but I mean, typically if you're fighting with the damn thing, well, a couple things you could do to prevent that from happening. When you're changing out the condenser fan blades and motors, put never sees on the shaft, on the end of the shaft. Make sure it's marine grade. Marine grade is obviously more apt to deal with water. And just put a little bit of caulk on the very, very top of
Say that again.
Caulk. You're an ass.
Fucking straight New England.
And what's that?
Straight New England accent.
I was trying to not make it sound like something else. So anyway, make sure that you're putting that stuff on the top where the hub and the shaft meet. So any rainwater that would potentially go in there and cause the two dissimilar metals to start oxidizing and rusting together, that's not done. Also, make sure that when you are replacing a condenser fan motor, put a piece of cardboard in the bottom. You're not supposed to put your feet on there. Sometimes you do it just to make sure that damn fan motor isn't going to fall through while you're taking it apart. And also make sure you take the cardboard out after. I was working with an apprentice and I didn't think I had to say it. I basically was like, yeah, use a cardboard, or sometimes, when the motors, that they're bolted to, they'll have a piece of plywood in the bottom. I was like, you can use that too. He's like, oh, awesome. So I'm working on some other stuff. He's doing all the condenser fan blades and motors. And someone calls me like a week later, like, hey, were you guys using cardboard on there? I was like, yeah, why? It was never taken out. I'm like, what? He's like, it was only one of them. You guys did a bunch of motors, but it was only one of them that he left it in there. I was like, I didn't think I had to tell him, but apparently I was wrong.
Yeah, you got to tell everybody everything.
I know that now. I know that now.
So the other thing is with the motors, like I said, OEM only. Usually, if I'm ordering motors, like I'm gonna order the blades too. Blades are like $70, and it's cheap insurance. Like Brett said, getting stuff off. Like I use that Lau blade puller. I mean, I'll usually get a summer out of it, because I'll throw the Dugga machine on there and just send it to the moon with a Milwaukee 1/2 inch. I mean, so it'll spin the blade off. It's either coming off or it's shattering the hub. So
So one of the things I've had to do in the past is, I had one that was stuck, blade was out, I think like a month or something like that, kind of like what we're dealing with now, and I basically had to drill out the shaft, and I did it enough to thin out the walls a little bit of the actual shaft of the motor once I cut it free. And I have a piece of steel stock in my truck, or at least I did, about 3 inches deep, with a hole big enough that it would prevent the hub from going through, but the shaft would. So then that way I could use a punch and hit it through the other side once I've loosened it up a little bit, just so I'm making sure that I'm not bending the crap out of everything.
Yeah, I mean that's one thing. Now, I mean, guys, just for example, like we're talking about these fans and everything, going up to a condenser, and it may look clean on the bottom. One is impacted. So an impacted condenser, two things, telltale sign: you're going to have higher amp draw on your motors, and you're going to have air coming out the side. If there's air coming out the side of the fan blades, whether it be a horizontal condenser, a single unit condenser, if it's not coming straight out and it's coming out the sides, it's an impacted condenser. It's dirty. The same thing will happen if it's dirty. Plug with cottonwood, you're going to have air coming out the sides, not the top. So that right there tells you it's impacted. So you need to wash it from the top down. Generally, what I do when I find this, I want to try to get volume. It's not so much pressure matters, but volume matters more when you're talking like thick like this. You want to have high volume. So if I have decent pressure, what I've been doing is I have a Milwaukee transfer pump, battery operated one. I've been using that, and it increases the volume and pressure. And I try to put as much water down there as I can in one spot. So like I will take it, and I have a big fireman's nozzle. I'll take it and I'll just move it slowly and just knock the shit down from inside. Or I will pour a ton of chemical in there and let the new bright, eat all that dirt out. I remember a lot of times, most of these stores don't get condenser coil cleaned.
Okay. Okay. Hold on. Let me just put one notation there. Do not use coil cleaner on particular condensers or gas coolers that you see a tag on there that says bronze glow. Bronze glow is an epoxy cover that they typically use near the oceans, so they get more longevity out of the condenser. That being said, if you use the condenser cleaner, the new bright on there, it will shear all that stuff off and get it stuck in the condenser. And then your customer is going to be really pissed.
Viper actually makes like a safe cleaner. I'm pretty sure, like the same people that make the new Calgon, not new Calgon. Is it new Calgon?
They have that green clean. I used to work at a chocolate plant out in
not new Calgon. It's people that make Nylog.
Oh, okay.
Refrigeration Technologies. They make a cleaner that's safe. It's not acidic like New Bright.
Yeah. So yeah, you got to be mindful with that stuff, man.
Well, yeah, and you got to watch the roofs too. But I mean, if you got to remember, a lot of these stores, their condensers aren't by exhaust fans. They're not getting greasy like a normal store would, so they don't get cleaned with chemical like that often. I mean, there's stores where I've cleaned one this week that I cleaned with water like 3 times, and it was coming out like halfway decent. I poured an acid on that thing, let it sit for a half an hour with the rack off, and started power washing it again. And it was just coming out black as a tire in like just chunks. Like that acid finally worked that stuff that's been sitting up in there, worked it all clean, and then everything started just pouring out of it. So, I mean, you got to remember, a lot of these don't get acid cleaned, and I cleaned it from the top. I pulled all the fan grates, and I went from the top down with a power washer.
So that's what's nice about some of the manufacturers. They actually, I think it's bone, where they have the two bolts that are on the side, and you can move that out, and then that whole top actually comes up, so you have complete access to that condenser. So it's a heck of a lot easier. Huh?
Yeah, that's a target requirement. Even the
Really?
even the Husman racks do it.
I
Like
didn't know
that
was
was
a
part of
requirement for
their
them.
every single rack we have, whether it's Husman condensers or bone condensers, they all have the hinged tops.
Gotcha.
So it's an option. I mean, you could obviously buy it, but I mean, that is the only customer I've ever seen have that.
Yeah.
They kick ass as long as some dickhead didn't take an impact to them and shove the rib nut bolts in.
Yeah, and in those condensers, that they have that C channel in there. Make sure that you do not have any rub through, since you're going to be opening up all of them anyway. Just check through, because it's going to save you so much headache. I'd rather change something like that, the wires that are in there, when it's not 100 and god awful Satan's.
And then do not use single wire like they use SJO cord.
As long as the wire requirements is fine, right? As far as the amperage. So I mean, you should. I mean, most of those fuses are set for 15 amps, so you should be able to get away with using that 12 gauge. You could typically run. You could actually run 14, because it's never going to be 100 feet from that from that contactor out.
I just run 14s. You're fine.
Okay. What have you been doing about the wonderful ECM type motors that are in some of these manufacturers?
Talk about the EBM piles of junk.
You said it, not me. I'm just, I just know that they're out there, and I've never had to replace one.
And they're heavy, and they fail like nonstop. So what we've actually been doing is retrofitting them to standard motors.
Really?
Mm-hmm.
Because those ones have. Hey guys, today's episode is sponsored by Westermeyer Industries Serviceable Oil Floats. Many oil separators contain an oil float to effectively meter separated oil back to the compressors. Westermeyer Industries has taken this concept and perfected it with their new line of serviceable oil floats. These floats feature an improved design with fewer components, allowing for greater manufacturer consistency and up to 20% increased oil flow versus their legacy models. These floats also feature an integrated magnet to shield the oil path from debris and have been field proven in supermarket applications. Westermeyer Industries offer replacement oil floats not only for their own separators, but also cross-compatible models for our competitor oil separators as well. You can find out more about the Westermeyer Industries serviceable oil floats by visiting westermeyerind.com/floats. Once again, that's westermeyerind.com/float. Let's get on with the episode. Well, wait a minute. Are those the ones that are connected to the VFDs that are in the crack condensers? Or is that different?
No, those things are junk. I can't wait to start retrofitting those things. No, I'm talking about like the EBM PAPS motors where they're all individual VFDs, or like the ZPAD or whatever other.
The ones that are like 8 months out.
Yeah,
and like $9,000.
Yeah, we replace those with standard motors.
I've seen a lot of captive air units that have a motor that looks a lot like it, but I don't think it's the MBAST ones. I think it's another manufacturer.
They actually sell a kit to replace those motors. Like it's a whole new top piece, bracket, a basket, a new blade, everything.
Yeah.
We drop them out, and then what we typically do, we'll do one rack, and then we'll bring the motors down the rack room. We'll put a new VFD in for those motors, and then after all the motors are gone off the other rack, they start to fail. Then they retrofit that rack.
Gotcha.
Yeah, those Husman condenser fan motors. Don't wire those drives hot. Trust me.
So I know obviously the correct thing not to do is not to put water on the condenser if you don't have to.
Last option. You want to make sure that all the condenser fan motors are running, everything's clear, it's not compacted, the air blowing out where the fan guard is not blowing out to the side. Basically, just so you understand what happens is when that thing. other redheaded stepchild before we bring up water.
Okay.
Non-condensables.
There's no such thing.
So, yeah, guys, especially on these racks where there's been questionable stuff done, do a non-condensable test. What you want to do is you want to shut the rack down. I generally just shut everything down. I don't pump it down. I just shut it down, force the fans on for a half an hour, check your saturation temperature. With a non-glided refrigerant, I want to see within a degree. Brett, you agree with that?
Absolutely.
Okay. With a glided refrigerant, I usually go plus or minus 3 or 4 degrees of the midpoint.
Yes, absolutely. Absolutely. I've never done a non-condensables test where it came up either straight liquid or straight vapor. It's always midpoint.
Yeah, I usually go like 3 or 4 degrees from midpoint. You got to remember some of these refrigerants have huge glides, but 3 or 4 degrees from midpoint. Now, what you want to do go ahead, Brett.
Oh, no, you finish that because I just want to make sure that I hit on something that could be causing high discharge pressure. Go ahead, continue.
Now, at this point, you have non-condensables. How do you get rid of said non-condensables? Well, there's 2 ways to get rid of said non-condensables. You could pull the entire charge, pull a vacuum, and charge it back as a liquid. Takes time. Or you could vent it off into a recovery tank several times.
On your paperwork, make sure that you write down that you recovered non-condensables.
Yes.
It is still illegal for you to just blow off what you think might be air, but and there's no way to really tell whether you are letting air out or whether you're letting refrigerant out.
I usually go till I see liquid coming out into the tank.
Absolutely.
And then I'll stop and I'll let it run for a little bit, and then I'll let it chill out again, and then I'll let the go until the liquid goes back into the tank.
Absolutely. Sometimes on the service valve, I've seen sometimes they'll braze in a sight glass, so then that way you can actually see the liquid go up to that valve
into the tank.
You do want to make sure that even though you're showing you might be like while it's running, or your subcooling is incredibly high when it shouldn't be in the summertime. Like I said, typically we like to see about especially in the summertime, it might be lower. Typical rack gives you about 5 degrees of subcooling. In the heat of summer, you might get 3, maybe 4. So it is going to be a little bit lower. But if you have excessive subcooling, like I'm talking 20, 30 degrees, it might not be exactly non-condensables. What I have seen in the past is receiver repressurization valve. Basically either the ORD or the CROT, the valve that's hooked up from the discharge line into the receiver. If this valve feeds in the summertime, what will happen is it will cause the discharge pressure and the receiver pressure to be almost exactly the same. That being said, the discharge pressure can't push out the liquid that's in the condenser, so it starts stacking progressively bad in the summertime, causing excessive discharge pressure and also excessive subcooling. So make sure one of the checks that you should be doing is valving off the receiver repressurization valve, the line going from the discharge line over to the receiver, and making sure that once you shut it off, what'll happen is if that's the case, your subcooling will go away, your head pressure will come down, your TD will be straight up, but then all of a sudden you'll watch the dial on the receiver go from 35, 45, 55, 65, 95, oh shit, and then you end up turning the valve back on so you don't pop anything off. What that's telling you, what happened was someone saw the rack running dry, where they saw the sight glass empty. They're like, oh, I'm just going to gas it up. They gas it up. They have this problem where the discharge pressure can't overcome the liquid and so on. So it just starts stacking in the condenser. And in the wintertime, it was fine. It would still run and function. But now that you've now caused that pressure difference from the discharge of liquid to not be the same, all of a sudden you now see that you have an overcharged receiver or overcharged system. I've seen this happen on one. I was at one store, 3 different racks. We had to pull 350 pounds out. All the CROTs were all bad. And it did the same damn thing. It's, high subcooling, high discharge pressure, messed up TD. And all of a sudden you turn that valve off and lo and behold, your receiver looks like it's going to start spinning around on the gauge, on the Rochester gauge.
Massive problem at Aldi with that.
Yeah.
Like almost every store. Except they're using ORDs, and what ended up happening is the heat reclaims are undersized.
Mm-hmm.
When the heat reclaim runs, you end up with like a 15-pound pressure drop from a discharge to the heat reclaim outlet.
Oh, shit.
And Husband put the wrong check valves in like probably 100+ stores. They were supposed to put 10-pound pressure drop check valves in there. I found 15s, 20s. What ended up happening is the ORD would keep injecting into the receiver because it saw that pressure drop, and then it builds and builds and builds. Then it starts blowing through the equalizer line on the receiver, and then it all equalizes for a second, and then all of a sudden everything drains out of the receiver, goes in the store, and then the condenser drains. And it's this vicious cycle of discharge trip, run, discharge trip, discharge, run. And in the meantime, the heat reclaim is constantly cutting in and out, so guys miss it.
Yeah, and then they waste a
Grab
bunch
that
of time.
sterile line. If it's hot, then you're injecting hot gas.
Yeah, the receiver repressurization should never, ever be feeding in the summertime, unless you live in Antarctica. Otherwise,
or you're on a cool rack with a huge defrost load.
What kind of rack?
Like a cool gas defrost Husband rack with like a huge coil defrosting. You could drop the head pressure. You could drop it pretty low doing that.
Gotcha.
If you're using those old school, 225 and 210 pressure control settings.
Gotcha.
So I mean, yeah, the last thing you guys want to do is put a sprinkler on, and then I'll be the first one to say that. But you know what? Last week I probably spent $800 on sprinklers. I'm not even exaggerating.
It's funny in Texas. Like usually at every single Home Depot around the heat of summer, it is almost impossible to find a freaking sprinkler in the middle of the summer. There's so much equipment. Same thing with split. Even like small split systems. Those micro channels on Heatcraft units. If you call the engineers, they'll tell you that they're only designed for a 95-degree ambient. So a lot of these convenient gas stations, where they just have not a back room, but basically a bricked in area where it just collects an enormous amount of freaking heat, and then it ends up being 120 degrees, and they wonder why the condenser's not working. Now, it's not supposed to be above a 95-degree ambient area. So if you're kicking hot discharge in from one unit to another, causing excessive temperatures and excessive discharge pressure, you're going to have a bad time.
So, yeah, I mean, water is like the last resort. But sometimes it is what it is. If the condenser is absolutely clapped out, there's nothing else you could do.
So you don't get yelled at from a customer, because they watch everything now. They watch water usage, they watch their electric usage, service calls. There's so many KPI dashboards. It's freaking insane. So one of the things you can do to help conserve it, because you don't want to just, hey, I'm going to go there in the morning, I'm going to turn it on. I'm going to go in the afternoon, I'm going to shut it off. So when I was back in Connecticut, we built these auto feeders. All it was a water solenoid hooked up to PVC with 2 hose fittings on the ends, and A19 that was activating the solenoid. So we'd strap the bulb directly to the liquid line. When the liquid line got up to 105 degrees, it would kick on the sprinkler, and then when it would cool down in the afternoon, it would stop the sprinkler.
All right, if you're going that far, that is ridiculous. Your customer needs to change their condenser.
Well, I know that, but I'm just saying. What did I just say about the remodel thing?
You're prolonging the inevitable and trying to make them happy with their KPIs. They could spend a little bit less money on KPIs and buy a condenser, and then make their KPIs back. You can't fix cheap. It's cheap trying to fix cheap with cheap.
I get it. I get it, but you do what the
You're
customer
enabling them.
wants.
It's like enabling a drug addict at that point.
Edit minute 40:05.
All right, let's talk about something else real quick before we end this up. Guys, there's a lot of things that go into head pressure issues. Like me and Brett were talking about, a lot of it's condenser. It's not all just the condenser, too. Superheat coming back to the rack. You guys would not believe how much of a difference, going from a 50-degree return gas temp to a 20-degree return gas temp or a 10-degree return gas temp makes. Getting that return gas temp down and getting your superheat down at the compressors tremendously helps that heat of compression. So as you reduce that heat of compression, that's your compression ratio, your heat made from compressing that. As that temperature comes down, that gas gets more dense, the compressor gets more efficient. But at the same time, now it's not as hot a discharge. If you get that discharge down to 180 degrees, 190 degrees from 200 plus degrees, now that condenser is doing less de-superheating and more subcooling. The less de-superheating you do in that condenser, the better. Okay. Now let's talk about this. Mechanical rooms being hot. Making sure exhaust fans are working in mechanical rooms. That's a huge thing. Okay.
Insulation on the pipes. Just as easy as just putting insulation on the pipes. That's one of the biggest things that gets let go that actually does help with sizing of condenser. I mean, if you're bringing back 20-degree cool gas or cool suction gas, but yet the motor room's 140 degrees and you basically have no insulation, it's the equivalent of probably putting 50-degree suction gas back into that compressor. So it's just going to kill your discharge temperatures. Is all hell.
So yeah, guys, keep the discharge temps down. Even on compressors, like we've installed Y10 valves on like Bitzers where they have a CIC module. We've installed 110s or Y10 valves and knock them down to 190s. Same with the Carlisles. I generally go with a 190. You're going to lose a little bit of capacity on the compressors, but you gain it back with the compressor running cooler.
So also those valves, the Y1037s that Kevin's talking about, they're it's a liquid injection valve. It's typically hooked up right on a liquid header going into the compressor, whether it be right in the suction, right in the side port, wherever the manufacturer basically tells you to go. Those things are rated sizing wise. If you've ever had to size one, there's a couple different factors. It's the SST, basically the saturated suction that you're running. It's also based off of your suction gas return temperature. And it's also sized off the horsepower of the unit. So if you had a shot in the dark, if you had a 25 horsepower unit running at negative 25 degrees saturated and running a 20 degree suction line temp, it might tell you that you need a half ton valve. If your suction line temperature is hotter than that, and the unit was not designed for that valve, in fact, might be undersized. We had a certain customer. They have a dual temp rack, and the saturated suction was set for minus 25, but they had like 20 different cases on there. But if out of the 20 cases, you were operating 2 cases on low temp. All the rest of them were actually medium temp. So that means that the mass flow of that cool gas coming back that should be stupid cold was not. And the technician was scratching his head. He's like, I don't know why it tripped. I don't understand. Like the amperage was fine. Temperature was a little warm. Yeah. But basically he couldn't come up with an answer. So when we looked at all the graphs and stuff, one, superheat was real high on the 2 low temp cases. Yes. But most of the problem is that the fact that the other 18 cases that were on there were returning, 40 degree suction vapor coming back to that compressor. So if the unit was sized from the factory to have a 20 degree suction and it's not running that valve might be undersized. What we actually ended up having to do is we were able to actually float the suction pressure up, lower the compression ratio, which lowers the amount of heat generated. And with adjusting the expansion valves on the low temp on the 2 cases that we're running, we were able to actually get the discharge temperature down by about 35 degrees.
Yeah, I mean, same thing. Head cooling fans, guys. Make sure these head cooling fans are operating clean. I walk in motor rooms all the time, and the bottoms of the head cooling fans are absolutely freaking plugged. Head cooling fans take a tremendous amount of heat off low temp compressors. Same thing with oil coolers. Make sure the oil coolers are clean.
I don't understand this. So I guess Copeland is doing away with oil coolers, which doesn't make any sense to me unless they redesign something in the compressor. Do you know something I don't?
No, I just know they're doing away with them. I would rather have them. I mean, they seem to help to me.
I agree. I know that they're doing away with them, and because we've had compressor, typically on a really low temp, like R22 type compressor, you will have the oil cooler because of the compression ratio, and there's typically 2 fittings on there. There's like a little horseshoe a horseshoe made out of 3/8 piping that's connected from one, where the oil cooler would be. It's basically a bypass. If you take that bypass off and you cap that compressor, you're going to grenade that compressor. That oil needs to go through that little horseshoe, whether it be through the horseshoe or through the oil cooler, in order to have flow for oil. So if you don't have that open, we're not putting oil into the crank. If we're not putting oil in the crank, we're going to have a bad time.
Yeah. I mean, just make sure those work, guys. Make sure your liquid injection works. Get the superheat down at the cases. Get it down at the rack. Make sure the insulation's good.
Subcooler. If that subcooler is not working, if the original design for that machinery was 50-degree liquid on that rack and you're running 110-degree liquid, now all of your compressors are undersized by about 25%. So if they're undersized, you're going to cause excessive suction pressure, which inevitably is going to cause excessive head pressure. And you're going to think something's wrong with a compressor. I've done it myself. Before I, became Captain Subcool, whatever the fuck they call me, I was looking into, I didn't understand why the rack was running such high pressure until I finally understood like how much capacity you actually gain when that subcooler is employed. Same thing with, any of the compressors, the scrolls that have the vapor injection. It's imperative to make sure those things are running.
Is huge. Like the heat of compression that is reduced by the vapor injection scrolls is tremendous. So I mean, making sure that those subcoolers are working on those racks will help the head pressure tremendously. You're reducing that heat of compression by a lot, and not to mention that is technically your inner stage of that compressor. So it actually ends up messing up the compressor by not having that inner stage in there, which is that subcooler. So that's one thing you want to really pay attention to and make sure you're not causing that heat to go in there. So, and then keeping those motor rooms cool. A lot of the motor rooms we've been installing lately have been putting in coils. We're hanging coils. Go ahead.
I was just talking about that, and I think that they made that part of the International Mechanical Code, because now all these racks have buku amounts of electronics in them, whether it be VFDs, IDCM modules, whatever have you, right? It's just there's so much heat being generated. So the idea is if we keep everything cooler, including the mechanic room, everything's going to be more well off.
Yeah, that, and it actually costs less money to cool that mechanical room than it does to run the exhaust fan.
Probably. Go ahead.
Because the other issue is that exhaust fan is putting tax on the building pressurization.
Unless it's separate, right?
Yeah, but I mean, all of our rack rooms are inside or on the roof, so we generally don't have very many behind the building anymore.
No, but most of the ones in Texas, they're either outside, like you said, outside on the roof, but typically in an outside mechanical room. It looks like it would be like a Seasons 4. It's basically a big old penthouse.
Yeah, I mean, obviously that you're not gonna put a tax on there, but they're still cooling off the buildings. It just helps with the equipment and longevity with VFDs and everything else. It definitely helps. I mean, we've added coils to rack rooms, and it's helped a lot. And it also helps, in the shoulder seasons, pick up some load too, where you could shift and pick up some load, cool the rack room down a little bit, and still have load to defrost.
That's something we got to cover one day. Load shifting.
Yeah, we can go over that. I've done some fancy stuff with load shifting, but again, guys, make the water the last resort. Don't just throw the water on there. I was chasing around guys that were throwing sprinklers on condensers and not hosing them down. If you're going to throw a sprinkler on there, make sure the damn thing's clean and it has good airflow. And if it doesn't, come back with a power washer. Even if the customer power washes, which none of them did apparently this year, come back and power wash it. Give it some acid. Get it cleaned up the best you can. I mean, if it's shot, bring it up to the customer. They may have heard it 95 times, but they can only push a shot condenser for so far. Financially, it doesn't make sense. I mean, what they're spending every year, after 2 years, it'll probably be paid off. I mean, from the KW and water usage. I mean, there's stores in Chicago right now with 5-6 sprinklers on a roof right now. I mean, you're telling me that water usage in the city of Chicago isn't gonna pan out for those condensers to get changed, especially when the utility pay probably 25% of it.
Well, like you said as well, I mean, with the compression ratio, I mean, if the thing has no fins on it left, and you're just left with a rows of copper, it's about time to do some work on there, replace that damn thing.
Well, I've seen these idiots going around with these lately. They've been using an air compressor, like a giant ass industrial Ingersoll Rand air compressor, and they're blowing these things out from the bottom. They're literally just pushing it farther into the condenser.
That's amazing.
I literally saw it, and they were out there at a store I'm at, and I'm like, this thing was literally blanketed. They didn't blow it off sideways. They literally jumped up on the roof. They roped up the hose, started up the generator or the air compressor, and just blew this thing straight up. I mean, it was just pure. Look, you're blowing out a small self-contained, but it was just blowing it right into the middle of the condenser.
So you're using a 50 horse compressor and you can blow out all that shit.
Yeah.
That's amazing.
And they're going around all the HVAC doing the same thing.
I'm just going to start a business, and I'm just going to drive around the country just cleaning condensers. Yeah, I enjoy doing that.
All right, guys. I think it's going to wrap it up for now for condenser coil cleaning, as it is hot in this room.
You got to get an air conditioner. All right, guys. Have a good night.
That was wonderful.
Bravo!
I loved that.
Oh, it was great.
Well, it was pretty good.
Well, it wasn't bad.
Well, there were parts of it that weren't very good, though.
It could have been a lot better.
I didn't really like it.
It was pretty terrible.
It was bad.
It was awful.
It was terrible.
Get him away!
Hey, boo!
Boo!